Good afternoon, everyone. So happy, so excited to be here. This is the first time I'm speaking about SCORP. There are some people in this room who know about SCORP, but this has been an absolute game changer for us. So that's what I'm here to share. For anybody who's curious about my last name, Nagavara, it's one of those notorious junctions, where there's a lot of traffic jam. So that's where I get my name from. I got that name before it became known as the traffic jam junction. So, here's what we're going to be talking about today. We'll do a little bit of context setting. I have two case studies, and in between those case studies, we will talk about SCORP, what, how. We will discuss the impact and then some takeaways as well. All right. Now, I work as a software architect for a company called Globalization Partners. We are in the employer of record domain, not getting into a lot of detail because time is limited, but we have presence in about 180 plus countries, and we have 100 plus wholly owned entities. We've been in the market for about 13 years, and as with any organization, we have been a very ops heavy sort of a business, and we've had some engineering division. Over the last 4 or 5 years, we've realized that what we have in terms of technology and engineering is not allowing us to scale the way we would like to, right? And so we've been on this transformation journey for the last 4 years, and it's really picked up momentum in about the last 2 years. So when we talk about transformation, it's not just technology, it's not just engineering. We are transforming our business. We are changing the way we operate business. We are changing our tech stack, the way we define our architecture, and we are changing the way we structure our teams, we structure our people in order to achieve agility and be able to deliver value quickly to the market, right? This session is going to have a lot of callbacks, and if you've been in some of the sessions I refer to, you will get this fully. Otherwise, I will still give a brief about what I'm talking. So this is how we build, right? We have an engineering team which is supposed to solve a problem. This problem is essentially a domain or a bounded context. In domain-driven design, this essentially translates into a bounded context, right? This is the boundary of the problem area. This is what you're trying to build, and each bounded context has its own cloud account. So if you've attended Sheen's session from day one, he talks about domain-driven design, he talks about team topologies. In terms of team topologies, this is a stream-aligned team, right? Now, we have about 40 such teams in the entire organization across 4 different geographies, and we have about, on last count, 65 bounded contexts, but this is growing, this is rapidly growing, right? Which means every bounded context resides and operates in its own cloud account, and AWS is our choice of cloud. What this means is the engineering team has full ownership of that bounded context and that cloud account. The engineering team builds and it operates, so they have full ownership, right? This is how we operate. And we do it this way because earlier when we had shared accounts and things like that, it's very easy to step over each other's toes. It's very easy for one team to unintentionally cause a regression in somebody else's work, right? So what we said was complete separation of concerns and proper boundaries being laid out for each team. But while this is great for the team, they also have to run it, and they have to run it well, right? So, all right, so let's look at the case study. This is a very, very simple bounded context. Okay, this is called the notifications bounded context. It does just one thing, which is it takes a request and then it sends out an email using SendGrid. Simple. While it does that, it also puts something in the database, and then when SendGrid says, okay, I've successfully sent it, it just puts out some events on the event bridge, right? This is a simplified architecture diagram, intentionally simplified, for this purpose. There are other things, but we will not get into that. Now, this bounded context went into production sometime in October 2023, and we are looking at how the workload has behaved over the next 9 or 10 months, right? Just before that, this is something that's important. When this workload started, it was a completely new team. People had just newly joined into the organization. They were very unfamiliar with serverless. So we are a serverless first company, as in we do use servers only when necessary, but we are mostly serverless, right? So the team was very unfamiliar with serverless. They came from traditional companies where, they've used Java, they're used to deployment, scheduled deployments, that sort of thing. And they thought, okay, notifications, we've done this 100 times, we can do it quickly, right? So, and they did quickly. Now here's where it gets very interesting. You'll see a lot of graphs, and I will try to interpret this for you. This histogram is the request count, there's latency, and there's cost. All right, so October 2023, this went into production, and a simple send email was taking about 25 seconds. Extremely unreasonable. So the team said, okay, we've got to do something about it. While this is happening, let's also, take a look at the traffic. The traffic is almost nothing, and then it, gradually increases. The cost shows some variation, and we will go through that journey, right? Now, in December, the team said, okay, this is a Java workload, and we've provisioned about 512 MB of memory. Maybe that's not the right number for Java. Let's go with 2 GB, right? So they over-provisioned. And they did notice that the latency came down, but only marginally and still very unacceptable. It's been 2 months into production. How many ever consumers are there are complaining, and they've been vigorously trying to understand what is happening. And with all that research, they realized, okay, Java is not going to work. I mean, right now for Java Lambdas, we have snap starts and things like that, but back then that wasn't there. So they said, okay, we have to switch to Node.js, and then they did. And now look at the difference that made, right? The latency came down to about 200 or 300 milliseconds, so something like 25 milliseconds it nosedived, right? This was fantastic, and look at the cost. It's not much different from, where it was. Okay. And then come April, they're observing that the traffic is increasing, but the cost seems to be increasing disproportionately. So they said, okay, what is happening here? And when they did that, they realized, you saw the event bus there, some of the rules were misconfigured. Now what happens is, at the end of an event bus rule, there is a lambda. And if something is misconfigured, the lambda keeps invoking, and that adds to your cost. So suddenly they are seeing an increase here, and probably this was the time when they added a new consumer, and they realized there's some misconfiguration there, which was causing this, okay? This analysis took some time. They actually, took some time to figure out, but they also noticed the cost is still going up. And this is when they realized that in order to debug this, they were pumping a lot of metrics into CloudWatch, and that was adding to the cost as well. So by the time this whole thing was figured out, and the cost actually came down, the request count kept going up. But throughout this, there was a lot of learning. They were just using the SCORP process to understand, talk to other people, and figure out what is happening. Right? Okay. Same SCORP review process. What is happening here is, these are DLQs, DLQ messages. DLQ messages are messages that are fired when something goes wrong, when there is a failure. So you can see there's a lot of failure here, it goes up, comes down, right? You can also see that the count of deploys is very low, right? And then it begins to increase. What happened was, this is notifications. When there is a failure, you have to retry. But in case of notifications, retry is not as simple as retrying, because you don't want the same person to receive the same email twice, and you don't want the email to be undelivered, right? So retries are extremely tricky in this sort of a scenario. And all these failures were actually causing a massive concern. Now, what the team said was, look, we started, we went from Java to Node, and all that is great, but our testing is still manual, and that is not helping. That is causing a lot of errors, and we are finding errors once something goes into production. We really have to shift left. What do? Let's automate this. right? So that's when this journey begins, and then they continue to automate, and then, they're at a very good position right now. When we talk about tests, and when we talk about automation, there are different kinds of tests. Again, something we learned in Sheen's session. There are unit tests, integration tests, contract tests, and all these tests came in here. Now imagine the kind of learning the team has had in this period, where they went from straight up deploying and manual testing all the way to automating, and what that did to the confidence of the team and confidence in their own work and their workload, right? And you can see that here. The number of deploys started going up. Like I said, this is a team that comes from traditional companies, which means there are scheduled deployments every 15 days, every month, things like that. But once they started automating and they started seeing an improvement, they said, okay, if we add more tests, it simply means we can deploy faster. We can deploy smaller chunks faster. And that started happening. Now the team is also building good behavior, right? Okay, this was a very interesting one. Different time frame, but this is the time when the team started adding additional notification channels. Things like SMS, WhatsApp, what have you, right? Can you see this? The blue line that's just moving far right for multiple months, right? You can see that the cost of test and production environment is somewhat similar, but the dev one was going, was simply increasing exponentially, and this was baffling for the longest time. When I was doing these reviews and I started seeing this as a pattern across multiple teams, I realized there's something that is not working here. After, I think, a couple of sprints, we realized that what was happening was, as teams were adding new features or new capabilities, they were also launching a lot of ephemeral stacks, except they were not ephemeral, right? Those stacks remained, they were not tearing down those stacks, and a lot of services that run in the background, like Inspector, which essentially goes and scans code in Lambda, that was running. So now you have multiple stacks into number of Lambdas, and that cost was accumulating. And you can see that in the dev cost. Now, we do have budgets and budget alerts and things like that. Somehow this didn't get caught. This was, our budgets are usually $75 to $100, and it should have gotten caught, especially across accounts. At an organization level, they should have got caught. It didn't, but it did get caught in SCORP reviews. All right, we will just come to SCORP in 1 second. Okay, so I've shown you one case study, and it looks great. What exactly is SCORP, right? Okay, so there is Well-Architected Framework from AWS, and I'm sure there are similar frameworks from other cloud providers. I also know there's like a cloud agnostic Well-Architected Framework as well. What this is essentially all the best practices that AWS has for all its services, very nicely formulated, as a framework, which architects, engineers can use while they are building and operationalizing their workloads, right? Now, framework is great, but what AWS also does is it gives you a tool. All these best practices are, they are broken down into different questions, and each team can go answer those questions and see how close they are to applying the best practices, right? So there is tool. And then at the end of that, it will generate a report. It will say, okay, you're compliant, not compliant, and then here are your risks and here are your improvement opportunities, right? And this is great. It is really a fantastic way of working. It really ensures that you're applying the best practices, you're secure, you're reliable, all that, right? Performant. But there is a problem. And the problem is the base well-architected questionnaire is on last count, I think it was 57 questions with at least 5 sub-questions. And then if you add some additional lens, like serverless and all, you're adding another 50 sub-questions. Now, what happens is, for a workload, you can do this once. It takes several hours, easily about 10 to 12 hours, and this is done over multiple days and multiple weeks. Now, there are competing priorities. You're still building capabilities. You have to deliver value. right? And this usually takes a backseat. And so what teams end up doing is they do this once. When they have designed the architecture of their domain-bounded context, they do this once, and then it never happens again, right? And that is a problem because your workload is evolving, you are adding new capabilities. How do you ensure that what you're building does not move far away from what AWS says are best practices? Okay. All right. So that is where SCORP reviews come in, right? SCORP is an acronym for the 5 pillars of well-architected: security, cost optimization, operational excellence, reliability, and performance efficiency. Now, there is a 6th pillar, sustainability, which you will not see here because we are a primarily serverless workload, but I will speak about it in just a bit. All right, so where did this idea of SCORP review come from? It came from this person, Michael O'Reilly, who happens to be my colleague, and these 3 people who have been my colleagues, they wrote this book called The Value Flywheel Effect, and this is about transformation, modernization, talks about 4 stages, and in one of them, the SCORP reviews are detailed very well. Michael O'Reilly was the one who pioneered this idea. It has been applied in multiple organizations, and this is what we are applying at GP now. And so the motivation for SCORP reviews actually comes from this book called 4 Disciplines of Execution by Franklin Covey. What Franklin Covey says is, you focus on one thing and you do it really well, because if you focus on multiple things, nothing gets done, right? So that's discipline of focus. Discipline of leverage, identify the measures that will indicate the success of your work. And then there's discipline of engagement, which is use a compelling dashboard, because unless you see what you're doing and how it is performing, you won't gain a good understanding. It's very difficult. It's like shooting in the dark, right? And SCORP reviews is essentially this, and then discipline of accountability. So now that you've done the review, you know where you stand. How do you take this forward, and who takes this forward? All right. Okay. So that is the theory of SCORP reviews. And so if you are an organization or a team that is just getting started and want to incorporate SCORP reviews in your organization, in your team, for your workload, here's the simple way of going about it. Right. So SCORP reviews essentially happen once a month, twice a month, but there is the first meeting. Now, everything I showed you, all those graphs, there were metrics, there were measures, and somebody collected that. Somebody put that in a dashboard, and somebody actually drew out those graphs, right? So the first thing we need to do is we need to identify what are the metrics that are important, that will help you understand how your workload is performing, what is the health of your workload, and ideally, these have to come, these map to the different pillars of well-architected framework. Some teams, in addition to this, also capture functional metrics, things like how many notifications did I send, how many bounced, how many delivered, and that sort of thing. The most important thing here is define metrics. I think there was a session that was happening this morning as well, where we were talking about ubiquitous language. Generally, we have terms, but everybody uses it in a very different way. So it's very important to define the metric. The simplest one that I see, which is often confused, is cold starts. Some people think cold start is the time taken before the Lambda execution starts, and some people think cold start is something that includes the Lambda execution time. So it's very important that while we identify the metrics, we also have a good definition for it, and everybody uses that definition, right? The metrics have to be easy to capture. If you have to perform somersaults to capture metrics, nobody is going to do it. We have to make this process simple to adopt, really reduce the cognitive load. So easy to capture metrics, usually all this will come from CloudWatch, right? Avoid heavy computation, we don't need that. Maybe it will come later as the team matures, but we don't need that at the first cut. And then define your baseline. Where is it that you want to start? Or what is the minimum acceptable criteria, right? Identify the frequency at which you're capturing metrics. Now, in all my graphs, you saw it was monthly. It was per calendar month. So identify that. A sprint or a calendar month is a good frequency. Longer periods are not great. For example, some teams, suggest, why don't I capture once in a quarter? No, that's too long. I mean, where is the fast feedback loop, right? If you're waiting for 1 quarter, you've deviated from the best practices by a mile, right? So use shorter periods, capture more frequently, create a dashboard. All right, so what do the metrics look like? Now these are the 5 pillars I was talking about. These are standard metrics that any team captures. Again, the trick here is to make this simple, reduce the cognitive load. So pick metrics that are easily understood by everyone, right? For security, the security hub findings, sneak findings, side-code findings, all your not linters, but static code analysis, and the ones that do code checks, security checks, and that sort of thing. Use that. Cost optimization. There's there's a cost dashboard. Figure out your cost across environments. Top spend services. For operational excellence, DORA is a very good starting point. Test coverage, those sort of things. For reliability, production incidents, one of the things I've been asking my teams to do is also put the count of RCAs they've done, because they do put a count of production incidents, but the RCAs are missing, right? So you see how as teams mature, you can also ask them to practice better engineering. So there's that. And then performance efficiency is easy, right? Latency, throttles, memory usage, errors, and that sort of thing. All right. This is what a SCORP dashboard looks like. Okay. Very simple. It's just a bunch of tables for every pillar. And then it says, these are my lambdas, APIs, what have you. These are my metrics across P50, P75, errors, counts, things like that. I'm sorry about that. Right. And then there's cost, month on month. Security, these are the security hub findings. What is missing in the first and third table is the month, right, that you see here. So month on month or sprint on sprint, whatever your capture frequency is, just capture that, right? Now, you can ask, why do I need this? And where do I put this? Where we put this is a Confluence page. We put it on a Confluence page for transparency. These are the metrics that get surfaced. It doesn't remain an engineering team. It goes to EMs, EDs, goes all the way up to our head of engineering as well. So complete transparency. You can put it in Excel. We all know Excel is not easy to work with. In Google Drives and things like that, it's very easy to get lost. So Confluence is where we put this. You can ask another question at this point. Why can't it just remain in CloudWatch? Why do I have to get it from CloudWatch and put it in another place? Because CloudWatch has a very limited retention period, isn't it? 90 days, 100 days, something like that. So, the trends that I showed you were 10 months, 15 months, 18 months, things like that. And what you really want to see is those longer trends. And again, I think on day 1, Naresh was talking about organizational metrics, right? And he was capturing it for 4 years and things like that. So there's value in capturing this at workload level, and then you can also see what this does at an organization level. How does this reflect on engineering practices across the organization? So that's why you want a place where this can be persisted beyond the time that CloudWatch keeps. All right. This is not working again. Okay. All right. Oh, it did. Okay, thanks. Okay. So this was the first meeting, right? This is the first time the team is meeting and saying, okay, we should do SCORP. And you've identified the metrics, you've identified the frequency, you've created a dashboard. Done, right? Now, these are the periodic team meetings. This happens within the engineering team. Usually it's the engineering team, engineering manager, principals, tech leads, whoever. And this is the time when the data is collected and you've updated your dashboard. This process of collecting the data and updating the dashboard shouldn't take more than 30 minutes, right? If it's taking more than 30 minutes, you're collecting the wrong metrics. It's very unlikely that it gives you a lot of value. It is taking a lot of time and people will eventually stop doing that, right? So this is the time you've collected the data. The team chooses, when to collect the data, and at that frequency they will also meet. So if it's per sprint, they'll meet once at the end of the sprint, or if it is month, they meet once at the end of the month. This is the time you review metrics. So all the outliers that we saw, the trends that we saw when something was going up, something was going down, This is the time you review the metrics, you analyze the trends and outliers. You identify improvement opportunities. You apply fixes, you observe, you regroup, you review. Review again. And this is the time when, as teams mature, and you can see this actually over, just if they've started in, let's say, January, by March, teams will begin to say, but this is not enough. This is not giving me enough information. Maybe I need to collect something else. Maybe I need a better picture. So in order to, have a more high resolution picture, I need to collect more dots. So, I need to collect more metrics. So that happens. This is what happens within the engineering team. This is the fun part. This is the SCORP review meeting that usually happens once a month. And I need to have a sip of water, so give me a second. How are we on time? Almost half an hour? Okay, good. Okay. So this is, so the power of SCORP is in this meeting, right? This is the meeting where multiple engineering teams gather. There's the architect who facilitates this meeting, and there's anybody else who's interested. Sharath, who's our product manager, he joins the meeting quite often. Our VP of the unit that I work closely with, he joins. The EDs join, the EMs join. Anybody who's interested, join. Engineering teams, sort of drive this discussion. Everybody else can listen in, ask questions, and sort of contribute to that discussion. This is a safe space to ask questions. The most important thing about SCORP reviews is to encourage conversation and move the conversation forward. There's no point in creating a space of fear or shutting down questions, because that really doesn't take us forward, right? So we learn from each other. We focus on trends and not actuals. Very crucial. It's very easy to say, oh, this number has gone off, why is it so? But maybe next month it'll come down. It's very easy to penalize teams when you look at one number and say, this is off, or tell teams, okay, you're doing great because 1 month, one number came fantastic, but you don't know what is happening. There are multiple factors that contribute to that number, right? So it's very important to focus on trends. It's very important to celebrate wins. And this is my favorite part, these two, which is when an architect facilitates these meetings, multiple teams are there, and everybody is saying, I am noticing the same thing. I have this exact problem. So we take this, go back into the architecture group, have a discussion, and then we say, okay, maybe there is like a common solution that needs to come up here. So we engage with the developer enablement team and come up with common libraries, pipelines, things like that. Or maybe we formulate ADRs. We say, okay, the teams are going off here. These options are available and they are great, but we need to put some guardrails in here. So we come up with ADRs. This happens, and this sort of impacts the entire organization. And then there is benchmarking. So we look at data across teams and we realize, okay, I think the benchmark is here right now. Maybe it just needs to go up one notch. The teams are performing better, the teams are maturing, and so on and so forth. So case study number 2, we'll go through this quickly because there's a lot of good stuff at the end of this. This is a location domain. Again, a very simple domain. All it does is stores hierarchy of locations. So India, states, Karnataka, Tamil Nadu, each state, districts. Very simple. So DynamoDB works perfectly, no problem. And they've optimized database designs, so they're able to sort of achieve latency and things like that. Perfect. Now comes the fun part. Here came Chandigarh. Okay. Now Chandigarh is a union territory of India, but it's also the capital of Punjab and Haryana. So you see how the hierarchy, which was sort of unidirectional, completely breaks, and you have multi-way relationships now. Now, not only do you want to go from India to Haryana, Punjab, Chandigarh, you also want to go from Chandigarh to Haryana, Punjab, and India, right? So you want to be able to traverse the graph in both ways. And the team realized, okay, DynamoDB not good enough. Let's do Neptune. Neptune is the graph DB from AWS, right? Okay, now this is the graph. So let's see what happened here. Now, this was DynamoDB, looking very nice, latency and all that. The moment they introduced Neptune, the latency shot up. Now, if you are an engineer who's looked at this, what is your first reaction? How will you deal with this latency? Removing Neptune is not an option, right? You've got to keep Neptune. What is the first thought that comes to you when you see this? Gene, you should know. Okay, the first thought is we should cache the data. Neptune, latency is too high. No matter how much we optimize our Lambda, this is not going to change because this is Neptune. Let's bring elastic cache or some in-memory cache, right? This started. And then the team internally had discussion. So again, yesterday I think in Ralph's session we were talking about premature optimizations, and this is one of those examples, right? The moment you see something shooting, you want to optimize it right there and pick the easiest solution available, but that's not great always. So the team said, in the conversation, we kept saying, really, do you need cache? Why don't you think about something else? The team came up with provision concurrency. Now, not going into details, but that does give you some latency improvement. It gave latency improvement, but you see the cost also sort of going up, but the latency improvement was not too much because the requests were going up as well. And provision concurrency can only give you so much leverage, not more than that. So they said, okay, now we will introduce an API gateway cache and let's do lazy loading. Again, it gave you some improvement. The cost was going up because anytime you introduce cache, it will add to your cost significantly, right? It was still not solving your problem. Your latency was still not where you would expect it to be. It was not even where you started at, right? So it was still not good. So then the team said, okay, maybe, now that we have gateway cache, let's remove the provision concurrency. They removed it, and then the latency went up again. So you see how the team is just trying multiple things, and they're trying to figure out what is the best way possible. And then when they did all this, finally they said, okay, we've done everything. There's nothing else I can do. Now is the time I introduce a cache, and they did. And then finally, the latency went down. The cost did go up, like I said. But what is interesting is as the request count is going up, the cost is steady, the latency is steady. And so now you've achieved your goal, right? Okay, so what about sustainability? Sustainability is the 6th pillar of well-architected framework. And in serverless workloads, the serverless lens of well-architected does not even have a question for sustainability. Because what sustainability says is you have to right-size your machines, your servers, you have to pick the right region and things like that. And with serverless, you're only provisioning what you need, and it dies at the end of it, right? Once it's served a request, it's going to die. And so for serverless, it's very easy. But if you are deploying servers, you can identify metrics related to that pillar. But even for serverless, with all the examples that I showed earlier, things that teams tried, wherever the cost was going up, cost is a great proxy for carbon score. Okay, so if your cost is going up, and if you can't find a justification for it, it likely means you're doing something wrong in terms of how you've configured your workloads, right? Okay, and now we will come to the impact. How much time do I have? Okay, great. All right. Now, the SCORP review meeting, these are the kind of conversations that we have. These are engineers of all levels of experience. There are junior engineers, senior engineers, principal engineers, staff engineers, architect, engineering managers, product managers, everybody, right? And this is the kind of conversation we are having. We have questions about multi-account strategy is great, but we are talking about 65 accounts into 4 environments. Isn't that like too expensive? Will that not become expensive? Will that not become complex to manage? Then we have conversations like that workload can achieve much better latency than us. How exactly is that happening? And then, things like my CloudWatch, so many logs are going into it. How do I ensure only the right logs go in? Because it's also, increasing the cost. Why do we encrypt PII data in events but not in HTTP API calls? All these sort of conversations. I need to do feature flagging, I'm releasing something. And we've been doing it using environment variables. Is that the right way to do? Or, should we consider something like AWS config? These are the kind of conversations that happen. In Sheen's session on day 1, I think Manish was asking a question that we have all these great ideas and great tools, but it's really a question of mindset. How do we drive the idea of engineering excellence, continuous improvement, to engineers in various teams across the organization, right? And if you look at these conversations, this is the common forum where people come, sit together, and discuss, right? And like I said, the most important part is this is a safe space, so people should feel free to ask these questions, find answers, all right. So what we've done is, because of these SCORP sessions, we have identified PII management patterns simply because the question came up there. We've identified some org level guardrails. Teams were doing things that were convenient but not desirable, so we added some additional guardrails. Teams were using some custom solutions and we said, no, there are better AWS managed solutions, so we should go with that. So now what is happening is, what happened in one team meeting is now spreading across all engineering teams, across the organization, across 4 geographies, right? This is what the practitioners say. These are the people I work with. Shruti, who's a new engineer, she says that SCORP essentially allows you to focus on the health of the workload while you're juggling multiple new capabilities, right? Dara Sherwin, who's our senior principal engineer, he says SCORP promotes the idea of ownership, right? And there are many times we've identified things in SCORP which you would normally not identify in your regular testing, load testing, and that sort of thing. Monica, who's our engineering manager and really responsible for the delivery of the workload, she says, WAF is a collection of good practices, and while many times people use it like a checklist, it is really a gold mine if you use it effectively, right? Okay, some best practices, do's and don'ts. Like I was saying, don't obsess over absolute numbers, focus on trends. There's really value in doing that. Don't pick all the pillars at the same time. It will feel intimidating. Start with the simplest ones. Cost is very easily understood. The moment you look at $1, you know what it is. Everybody understands that. So start with performance and cost. And then, like I said, as the team matures over 2 or 3 months, they will start saying, we need this also, we need this also, right? Don't start with benchmarks set by others. Usually organizations have benchmarks. They say, okay, 800 millisecond lambda latency, average latency, P50 latency, whatever. That may be a lot for somebody who's starting afresh in this process. So start with a baseline, right? And then you will arrive at, maybe you will arrive at benchmarks for that workload. Maybe they'll be better than organization benchmarks, right? Now this is one bad habit some teams have picked up, which is there was one person, usually the junior most in the team, who was assigned to collect metrics. Very bad idea. This is not a one-person job, this is team effort. SCORP, well-architected, is everybody's responsibility. If you're writing 5 lines of code, or if you're designing the architecture of your entire domain, SCORP is everybody's responsibility, right? Don't stop at conversations. Conversations are great, but at the end of it, teams must take home actions. We must identify patterns, formalize, institutionalize learnings. We should never pit workloads against each other, pit teams against each other. I was having a conversation with Naresh, and he was asking me, why don't you gamify? So you have teams, why don't we say this team is doing better than this? Maybe reward the team and things like that. That won't work, because each workload, each team is different. And to say the same yardstick applies to all, essentially what that will lead to is teams fudging metrics, right? What we have done is, by not doing this, we've not had a single instance where teams have shown some numbers that aren't actual, okay? So we really need to create safe space for inquiry, discussion, and really not pit teams against each other. It's very tempting, but not a great idea at all. Don't penalize teams, celebrate wins, surface the metrics. Instead of pitting teams against each other, surfacing the metrics is great. Let it surface up all the level, and then teams get recognized and rewarded, so that's great. All right, key takeaways. SCORP is a super powerful tool, right? The engineering team understand the health of their workload, they can improve the workload continuously, and they can evolve the workloads consciously. Not take drastic decisions, sudden decisions, without knowing what is in store, right? So for the architecture team, it's great because this is the forum we have to drive common understanding across teams, right? And then we identify gaps, patterns, we formalize decisions. And for the leadership, this is great because this is one opportunity to build high-performing teams. You can see how the teams are performing. You can see how the workloads are performing, and then so you also know how the teams are working to make that happen for the workload, and you can deliver value faster. And with that, the last thing I want to say, and this is what I took from Bjarte's keynote from day one, when your measure becomes a target, it ceases to be a measure. So numbers are great, but there's also this famous quote, I forget by whom, which says, if you strangle the numbers long enough, they'll sing any song you want, right? So we've got to be cautious. This SCORP review is great, and you can really drive team behavior across the organization, and that is how we have to use this. So, yep. With that, thank you very much. I enjoyed speaking here a lot, and this is the QR code for my LinkedIn. So if you would like to connect, I'd really appreciate conversations. I'll be outside, and we can talk more about this. Thank you so much. Yes, yeah.
Any